Alright, I am back with more exercise solutions, but this time I've passed my algebra requirements, so I don't need to focus on exercises on classes that I don't enjoy working on anymore. I get to focus on classes that I really enjoy. And for that, we're doing computational differential equations. So we're going to be going through exercises from this textbook. And so let's start with this one. Chapter 5, problem 7. Compute formulas for the linear interpolant. And we're going to go through points a and b plus a over 2. So we have some like number line going from like points a to b. And so we're just going to interpolate between a and the midpoint of this interval. And then plot the Lagrange basis functions. So to do that, basically in the textbook we get a formula for the interpolation. Basically what you do is you take, it's like for each point, like if you just have points A and B and you interpolate between these 2 points, then this interpolation, at least pi 1, the linear interpretation, or interpolation, not interpretation. For each point, you just evaluate the function at that point and then multiply by this Lagrange polynomial, which is given by, you take x minus, well, you could just look in the book for the formula. But this is what you get. And basically, instead of going from a to b, we want to go from a to b plus a over 2, the midpoint. So basically what we do here is we just replace b with this formula up here, and when we do that we get this thing. So we get this fractiony thingy, and then we basically just do some algebra. So we'll get f of a times this thing plus f of the midpoint times this thing. So then the corresponding basis functions are this thing here and this thing here. Of course we just specify those down here. And so we want to plot them, and in order to plot them, we're actually going to literally plot this. And so we need to choose points A and B. So let's just go with the easy route. Let's do A equals 0 and B equals 1. I could have done A equals 0 and B equals 2, but that's a little too easy. From a equals 0, b equals 1, then we just plug in a and b and we get these 2 lines here. And so then we obtain the following graph. And it's just lambda 0 is just, let's see here, 1 minus 2x, which is this line coming down here. And lambda 1 is 2x, which is this line coming up here. And of course we're going from, on the x-axis we're going from 0 to 1/2, and on the y-axis we're going from 0 to 1. And this is what we'd expect from this thing. And yeah, so not only is this like really neat, but like we actually have a picture here. We can actually literally see what's happening, and I think that's really cool. But other than that, I think this is just more of a warm-up exercise. And yeah, that pretty much finishes this.